Math 3, Unit 5, Semester Final Review Notes. Okay, so in Unit 5, we did a lot of rational functions. So on each of these, you just have to be careful for excluded values when you solve for x. So we're not going to worry about it so much when we're simplifying, but just remember that when you solve for x and get an x answer, you want to make sure that that value wouldn't make your denominator 0. Okay, do you guys remember that about excluded values? Okay, so on all these, we're just going to factor and simplify as much as we can. Okay, so on A, looking at the top, is there anything I can do? Good. So we can factor out a 6. And we're left with z plus 2. Okay, on the denominator. Whenever you have a number in front, always check to make sure that number is not a GCF. In this case, is that number a GCF? No. So what do? Good. Multiply 2 and 6, which makes 12. And then my adding number is 7. So what numbers multiply to be 12 and add to be 7?
43.
Good. And so when we write this out, it's 2z squared plus 4z plus 3z plus 6. Okay, and then we factor by grouping. And so in my first group, what can I take out?
2z.
Good. And we're left with z plus 2. In my second group, I can take out a 3, and I'm left with good. And so that means that the denominator over here is going to be what?
2z plus 3 x z plus 2.
Okay, 2z plus 3 and z plus 2. Okay, the one thing to remember is that anything that has adding and subtracting, remember, is stuck together like glue. And so the only way that you can cancel anything is if the whole thing is the same. So do we see anything here that can be canceled?
Z plus 2.
The z plus 2 is good. So each of these have a z plus 2. And so we are left with 6 over 2z plus 3. And again, the bottom part is connected like glue, so we can't reduce anything there with the 6. Okay? All right. Moving on to B. Okay, can the top be factored?
Yes.
Yes. What does it factor to be?
Y minus 4 y plus 4.
Good. Y minus 4, y plus 4, because it's a difference of squares. If you wanted to, you could rewrite 16 as 4 squared. Now, this is over 4 minus y. Now, is 4 minus y and y minus 4 the same? No. Who remembers what we do in order to make them the same?
Take out a 0.
Very good. We take out a negative. So if I were to take out a negative 1 here, that would make this 4 a negative and the y a positive. So I'm going to write that down here as negative 1, and I'm going to go ahead and flip it around now. So we have a positive y minus 4. So now both of these are y minus 4s, so we can cancel them out. And the negative 1 can go in front of the first parenthesis there, so we have negative and y plus 4. They could also distribute the negative through for a multiple choice answer, and your answer could be negative y minus 4. Okay? Any questions on B? Okay. C. On the top, can we factor anything out there? What? A 3. Good. So we're going to take out a 3, and we're left with 1 minus 3d. Okay, denominator. Can I factor anything out? Is there any GCFs? No. So what do? Good. Over by 6. And so 6 times negative 1 makes negative 6, and then I have a 1. So what numbers will multiply to be negative 6 and add to be a positive 1?
Positive 3 and negative 2.
Very good. 3 and negative 2. So we're going to go ahead and write this to the side. So I have 6d squared plus 3d minus 2d minus 1. Okay, in our first group, what can be factored out? Good. And we're left with 2d, good, plus 1. Okay, the second group, what do you think I'm going to factor out? A negative 1, good, because we need it to end up being a positive 2d plus 1. Okay, and so then that ends up factoring to be what? What's going to be in my denominator? Good. Okay, are these exactly the same? No. So either on the top or the bottom, it's up to you. We need to end up taking a negative out of one of these in order to make them the same. So I'm just going to go to the top. I'm going to make this 3 a negative 3, which will make the 1 a negative and the 3d a positive. So now these parentheses are the same because we have positive 3d's and negative 1's. Is that good? Okay, so these cancel, and so we end up with negative 3 over 2d plus 1. Okay, any questions before we move on to something a little new? Okay, so we'll notice that we have two fractions multiplying here. It's the same as what we've already been doing. It's just that anything on the top can be reduced with anything on the bottom. It doesn't matter where it's at, it just has to be on the top and the bottom. Okay, so in a way we kind of have like 4 things we have to factor here now. Okay, so on this first fraction, what could I do to the top? Very good. So we're going to take out a 3x, and we're left with? Good. Okay, when we go to the denominator on that one, is there any GCF I can take out? No. So I'm going to do this to the side again, just so that it makes it easier when I come down here for simplifying. And so 2 times 15 is 30. So what's going to multiply to be 30 and add to be 11?
6 and 5.
Good, 6 and 5. So we have 2x squared plus 6x plus 5x plus 15. So in my first group here, what can I take out?
2.
Good. 2x, and I'm left with x plus 3. In my second group, I can take out a,
5.
and I'm left with x plus 3. So that means my denominator here is going to be, good, 2x plus 5 and, good, x plus 3. Good. Okay, so multiplying, and then over on this side, 2x plus 5, can I do anything there?
No.
Nope. And do you guys remember how to factor with the cubes?
Take the cube.
No. So the first thing you want to do is change this so that everything's in terms of cubes. Okay? And so that means I'm just going to rewrite this as x cubed plus 3 cubed. Does anybody remember the next step on this once you write those as cubes? Okay, so your first parenthesis ends up being whatever is here without the cubes. So that means it would be x plus 3 is my first parenthesis. So I just take the cubes away. Okay, your next parenthesis, the first term, we square this first term. So that means we would just have x squared, because x times x would make x squared. The middle term is where we multiply these together, and 3 times x is, but you take the opposite sign. And then your last term is this last term squared. And that's it. And I'm trying to think back because I think I maybe had you guys like write out all the things that you're multiplying, like x times x times x times 3 times 3 times 3. Does that kind of make sense? So if you want to do it that way, x and x and x and 3 and 3 and 3. So remember, that makes your first term, that makes your second term, and that makes your last term. And then you have to remember, we talked about SOAP. Do you guys remember that? Where the first sign is the same as your original problem, meaning plus. Your second sign is the opposite. And then the last one will be always positive. Okay, do we see anything that can cancel? Good. X plus 3's, and you could cancel this one with this one or this one with this one. It doesn't matter. Okay, anything else that can cancel?
2x plus 5.
2x plus 5's. Can anything else cancel? No. So on the top we have 3x, and then our denominator is x plus 3 and x squared minus 3x plus 9. Okay. Example E. What do you notice we should do first on example E? Good. You have a GCF, right? Which is what? An X. I'm going to do this first up here because I know it's probably going to end up factoring further. So I'm taking out an X, and then I'm left with x squared minus 6x plus 8. Okay, and so on this one we're looking for something that adds to be negative 6 and multiplies to be a positive 8. So can we think of any numbers? Very good. Negative 4 and negative 2. So we have x, and we get x minus 4 and x minus 2. Okay, the denominator here, we're looking for something that adds to be negative 8 and multiplies to be 16.
2 negative 4's.
Very good. So we have x minus 4 and x minus 4. Okay, what is going to happen next? Good, we're going to change division into multiplication. And we kind of talked about this just a second ago, or somebody mentioned that, the KFC. So we keep the first one the same. We're going to flip our second fraction and we change it to multiplication. Okay, so what's going to happen here? We're going to flip this. Okay, and so if we're going to the top, what's going to happen on the top? So let's pretend like we're flipping this around. Okay, so this 10x squared minus 40x is going to the top.
We're going to take out a 10x.
Very good. And if you want to, you could rewrite it here. We can flip it if you want to first. Oops. So yeah, we can take out a GCF of 10x. So I'm going to just write this on top here. I take out a 10x and I'm left with x minus 4. But can that factor any further? No. And so that just goes on the top, 10x and x minus 4. Okay, and what am I going to do with the x cubed minus 8? Good. We would change this to be x cubed minus 2 cubed. So everything's a cube, right? And what would be your first parenthesis there?
X minus 2.
X minus 2. Do you guys want to do it with writing out all the x's and stuff? Okay. So x, all 3 x's, and then the 3 2's. So what's the first parenthesis, or the first term in the second parenthesis?
X squared.
X squared. And then the next one will be,
Minus 2x.
it'll end up being a plus 2x. Now, why is it going to be plus 2x? Because remember your SOAP, same sign, opposite sign, okay? And then the last one is going to be a plus 4. Okay, so we can go through and start reducing anything that we see. So what do you see first? X minus 4s. Okay, anything else?
X minus 2.
X minus 2s. Anything else?
The other two x minus 4s.
Good. Anything else? Okay, so just be careful that you don't miss anything. But notice here on the top we have left an x and a 10x. So what does that make? 10x squared. We multiply together. And then the denominator, we just have x squared plus 2x plus 4. And could I cancel out these x squareds? No, because the bottom's connected like glue because you have those pluses and minuses, so everything's connected together. Questions?
So since there's a 10x and an x, you just multiply them and you get 10x squared?
Mm-hmm.
Okay, so whatever's left over.
Mm-hmm. And since these didn't have parentheses or anything, you're just multiplying those together.
Yeah.
Any other questions on those? Okay, so now we're moving on to adding and subtracting. And so in order to add fractions, you need to have what?
Common denominator.
Common denominators. Are these denominators the same?
Yes.
Yes.
Yes. So we can go ahead and combine things together. Okay?
See.
And so we're going to start with, we just have our 5x, and then negative 17 and a positive 2, what does that make? Negative 15. Okay? And then this is over our denominator, which is x squared plus 5x minus 24. So far, so good? Okay, and what do you think we'll have to do next?
Simplify.
Yeah, simplify. Can you factor the top? Can anything, what can we do?
Take out 5.
Good, we can take out a 5, and we're left with
X minus 3.
x minus 3. Good. Okay, the denominator, we're looking for something that adds to be 5 and multiplies to be negative 24.
A negative 8, or no, positive 8 and a negative 3.
Good, positive 8, negative 3. So x plus 8 and x minus 3. And then hopefully we realize that we have two x minus 3s, one on the top and one on the bottom, so those can cancel. And we are left with 5 over x plus 8. Okay, are we good? Okay, G. What am I going to do on G? Are those denominators the same? No. So what could I do in order to make them the same? Good, take out a negative 1. And so I'm actually going to do it on the second one. Okay? So when I take out a negative here, this becomes a negative and this becomes a positive. Is everybody okay with that? Now this minus sign, I'm going to bring it to the top of this fraction. If there were multiple terms there, you would have to distribute the negative to all the terms. But in this case, there's only a negative 10. So this just becomes a negative 10, and then this negative goes away. So remember, anytime you have a fraction, the negative can go at the top or the bottom, right? So since I took out the negative, I can end up bringing it to the top. Is anybody confused by that? Yes? Okay, so are you okay with taking the negative out of the bottom? Okay, so that means I'm going to rewrite this. We have 5x over x minus 2. And then you can have this as a plus, and we have a negative, and this becomes negative 2 plus x.
Please pardon the interruption, but do any of your students happen to drive a white Dodge pickup?
Anybody?
It's none of you guys?
Hires is doing a study session, so she might have.
Oh, that could be. Thank you.
You're welcome. Okay, and we have the 10 here.
I know who drives it, but he's not on this list. His name is Jordan Gray.
So I wonder if he left his lights on or something.
They parked in a spot. He's like,
Okay, are you okay with that right there? All right, so this minus sign, we don't want it in the denominator because we want the denominators to be the same. Okay, if I had like, let's say 1 over negative 2 like that, I could have the negative with the denominator or on top. It doesn't matter because you could write this also as negative 1 over 2. Okay, so what happens is this negative sign right here, instead of it being with the bottom, I'm just going to bring it up to the top. Okay, so that's how I make this a negative 10, and then this can then go away. So I'm just kind of switching where I put it. But if there were multiple terms on top, I would have to put it to all of them. Just like I took the negative out of all of them on the bottom, you would have to put it to all of them on the top once you do it. So we're just kind of changing. Is that better? Okay. So now I would write this as 5x minus 10 on top, because I can't combine anything there, over, and we're just going to rewrite that now as x minus 2. Is there anything more I can do in this problem?
Take out a 5 out of the top.
Good, take out a 5. And so we take out a 5, and I have x minus 2. My denominator, I have x minus 2. My x minus 2's can cancel, and so I'm just left with 5.
Cinco.
We good there? Okay, so on h, are my denominators the same?
Yes.
Yes, but what am I going to have to do with that minus sign?
Distributed.
You have to distribute it, okay? So we're going to take the minus sign, and we're going to distribute it to the top. Because if I distribute it to the bottom, it's not going to help me out at all, right? It's going to actually make the problem worse. So we distribute it to the top, and so we get a negative 3x and a positive 2, and then this minus changes to a plus. Are we good with that? Okay, so now we're just going to combine like terms. So 5x and negative 3x makes 2x plus 2 over x plus 1. Good. Can I do anything else?
You can simplify the numerator to 2x plus 1.
Very good. Over x plus 1. And once I do that, I can, good, cancel out the x plus 1s, and we are left with 2. Okay, any questions before we move on? Okay. I. What do I need to do there on I?
Distribute.
Very good. You're going to distribute this negative because our denominators are the same, but we have a minus sign, and so that needs to go at the top or the bottom. We're going to make it go at the top. So we have a minus there, and we change this to a plus. So when I write this now, I have what on the top? 3x minus 9 over good. Okay, what can I do now? Good. So we're going to take out a 3, and I get x minus 3 over, in my denominator, what can multiply to be 4, or sorry, multiply to be negative 21 and add to be 4? So it's going to be x plus 7 and x minus 3. So my x minus 3's cancel out, and we're left with, good. Oops. Okay, J. What's wrong with J? Right, they need common denominators. Okay. So what will I do for that? What would be the common denominator?
X squared plus.
Or let's just write it in factored form. So my common denominator would be x plus 1, x plus 4. Are we all okay with that? Okay. So since this would be my new denominators, because this one already has an x plus 1 on it, what am I doing in order to get it to be x plus 1 and x plus 4?
Did you have to like do it to the
Exactly, very good. So I would need an x plus 4 here on the bottom, which means I'd have to also multiply the top by x plus 4. Are we good with that? And so I would go ahead and simplify this. We have 3 times x plus 4, so that's going to be 3x plus 12. Is anybody confused by that? Okay, so what am I missing on the second fraction then? X plus 1. Good. So we have to multiply the top and the bottom by x plus 1. Also notice there's a minus sign here. Do we want to go ahead and just take care of the minus sign right now at the same time? So we could go ahead and make this a minus 5 and change that to a plus. And so I could go ahead and change this one here to a plus now. And then we have to distribute the negative 5 through. So negative 5 times x is? Good. And negative 5 times 1 is? Negative 5. Okay, so now we can combine like terms. 2x and negative 5x makes? Negative 2x. And then 12 and negative 5 is? Positive 7. Okay, and that's over x plus 1 and x plus 4. And that can't be simplified. Okay. Do you notice anything about k? They aren't the same denominator, but what do you notice about this denominator?
Ew. Ew. Get that off. Get that off. Get that off. That's so weird. It just fell from the sky.
From the sky.
That's important.
Here. It's just,
And it's gone.
oh my goodness.
Okay.
I think it's on
I
this.
apologize.
I'm just kidding.
I was gonna say,
All right.
And it's on record.
Yes. We're fine. Okay. Spider from the ceiling.
No, it was something wrong.
Okay. So if you notice on this denominator, you could actually factor out a 2. Did you guys see that? Okay, so what would end up being my common denominator in this problem? 2 times x plus 5. Okay, because they both need to end up being the same. Now, the first fraction already has that denominator of 2 times x plus 5. So that means that the 3x plus 1 just stays the same. On the second one, I still need a 2. So that means we are going to multiply the top also by a 2. So what do we end up with? Good, 2x plus 24. Okay, so then we combine our like terms. 3x and 2x makes 5x. Good, plus 25. All over 2 parenthesis x plus 5. Can I factor anything out? Good, we can take out a 5. And we're left with x plus 5 over 2 parenthesis x plus 5, right? And so x plus 5's cancel out. And we're left with 5 over 2. Jordan, you look.
Why did we multiply the second fraction by 2, equivalent by 2?
Good. Can anybody tell us why did we multiply that second fraction by 2? So in order to get common denominators, we need both of them to be 2 times x plus 5.
Oh,
And since this one was already x plus 5, we have to just multiply top and
Whatever
bottom.
due to the bottoms.
Yep,
Okay,
exactly.
thank you.
Any other questions there? Okay. What do you notice about L? There's an equal sign. Good.
Yes.
We're going to actually stop here. We're going to have to split this into 2 days. Okay? So, we're going to stop.